Greetings, class. This is Dr. York-Hammons. We're covering some information from Chapter 8, Section 2. We are still testing differences between means for two samples. They are still independent samples. The difference between Section 1 and Section 2 is that now the population standard deviation for Sample 1 as well as the population standard deviation for Sample 2 are both unknown. In Section 1 they were known and we could do a z-test. But in Section 2, where we don't know the population standard deviation for each sample, we have to do a different type testing. This is very similar to Chapter 7 when we were testing one sample and we didn't know the standard deviation for that sample. We had to do a t-test, but there were some conditions that had to be met for us to even be able to do the t-test. And those conditions were that the population standard deviations are unknown, the samples are random, they are independent for testing difference between means. These are the four conditions. And the populations are normally distributed, or you notice that each sample size is at least 30. So again, these four conditions on page 428 of your e-text must be met in order to use a t-test to determine the significance of the difference between means of two samples. I'd like to bring your attention to some information lower on that page 428. It talks about the two-sample t-test for the difference between means. So it says a two-sample t-test is used to test the difference between two population means, mu1 and mu2, when, first of all, the population standard deviation for both samples are unknown, the samples are random, they're independent, and the populations are normally distributed, or the sample sizes are both greater than or equal to 30. So the test statistic is the sample mean for sample 1 minus the sample mean for sample 2. Now I'm bringing your attention to this point right here simply because my stat lab is going to ask you what is the test statistic, and you need to know it's just the difference between the sample means. But then they're also going to ask you to calculate the standardized test statistic that you get when you run the t-stat test, and the StatCrunch will calculate the difference between the means compared to the difference between the population means. You subtract those and you use the sample standard deviation to compare the two for the two means as an approximation to the standard deviation for the population for each set. Now, the other important information we need to talk about is variances for the sets. If they tell you the variances are equal, you use the degrees of freedom equal to n1 plus n2 and subtract 2. If the variances are not equal, you pick the smaller of the two sets, the smaller sample size, and then subtract 1 from that sample size. Now, when you are in StatCrunch and you're doing the z-test statistic, it will simply give you a box to check. Either the variances are equal, you check the box, or if the variances are not equal, you don't check the box. So either we pool them or we do not. And so I just wanted to bring your attention to this idea that there's a difference in the test whether the variances are equal or the variances are not equal. Now on the next page over, there's some more information. There's a flow chart, and we need to bring your information to the flow chart here, because this differentiates being able to use a t-test as opposed to a z-test for two samples. So it asks you, are both the population standard deviations known? Well, if the answer was yes, you could go towards using the z-test if the populations were normal or our sample sizes were greater than 30. That was in section 1. But if the answer is no, that we do not know both those population standard deviations, then we still have to ask the questions, are the population normal or are both sample sizes at least 30? If the answer is yes, then we can go ahead and run to the t-test depending on whether the variances are equal or the other degrees of freedom if they're not. The other option is if they don't tell you that the populations are normal or your sample sizes aren't at least 30, you can't use either the z-test or the t-test. So you would have to go back and revise your sampling information and at least get sample sizes bigger than 30. So I wanted to make you aware that they might ask you a question where you couldn't use the test, either test at all. I've decided to go to the exercises at the end of the section 8.2. We're on page 432 of your e-text. I'd like to look at number 4. They tell you that you're given the alternative hypothesis here, and that mu1 is greater than mu2, that alpha is equal to 0.01, the sample size for sample 1 is 12, and the sample size for sample 2 is 15. Now our instructions say to use the table 5 in appendix B to find the critical values, but since this is a t-test, since we do not know the population standard deviation for either sample 1 or sample 2, we can still do a t-calculator to find those critical values. We just have to be aware of what type of test, whether it's a left-tailed, right-tailed, or two-tailed test. Now, they did tell us that the samples are random and independent, the populations are normally distributed, and the population variances are part A equal or part B not equal. So we're actually going to do two separate graphs, one where the variances are equal and we pool the variances, pool the sample sizes when we find our degrees of freedom, and then when the variances are not equal, where we look at the smaller of the sample sizes, down here, the smaller of the sample sizes, and only use one degree. We use a degree of freedom that's one less than the sample. So let's go ahead and go to Stat and Calculators. In this case, we're going to go to a t-calculator because we do not know the standard deviation, the population standard deviation for either of the two samples. Now, number 4, that's the one we're going to look at first, says mu1 greater than mu2. If we have the greater than, that's going to be a right-tailed test. So we're going to do greater than on our inequality on the calculator. Our alpha value is 0.01, so we type that into our area, 0.01. That's our probability, or the area that we're going to look at to find the critical values. And we're going to start with part A, where the variances are equal. So for part A, if the variances are equal, we take N1, add it to N2, so that's 12 plus 15. I'm just going to type this in here and then I'll pick a number. So that's going to be 12 plus 15, and then we're going to subtract 2, 1 degree of freedom for each of those samples. So 12 plus 15 would be 27, and if we subtract 2, that would get us to 25. So this expression here is equivalent to 25 for the degrees of freedom. And if I click compute, it says that the value for my critical value is 2.485. And you know, I'm just going to go ahead and copy this, Control-C. I'm going to copy that. I'm going to come to my table. So I'm going to have to close that calculator. I'm going to come to my table, and I'm going to do what they refer to as a critical value. They call those critical values T sub 0, or T sub O. So our T sub O is equal to that value that we got going to let me type. All right, I'll type it in up here at the variable. T sub O for part A is 2.485. Now we need to find T sub O for part B. Now part B is where the variances are not equal. The variances are not equal. So if they're not equal, you pick the smaller of the two sample sizes and subtract 1 from that. You do n minus 1, in this case n1 minus 1, so our degrees of freedom would just be 11. So let's go back up and go to Stat, Calculator, T. We're still doing a right-tailed test. It's a greater than, so I do greater than. I know my alpha value was 0.01. And here, my degrees of freedom, I'm just going to remind you, the sample size, the smaller of the two sample sizes was 12. I just subtract 1 from that. And when I do that, my actual degrees of freedom is 11. 12 minus 1 is 11. So when we compute, our T sub 0 is 2.718. So I'm going to do a Control C to copy that. And I will close my table. And for part B, Control V. So there is our T sub 0 for part A and our T sub 0 for part B. Part A is where the variances were equal and we pooled the sample sizes. For part B, the variances are not equal and we use the smaller of the two sample sizes. So let's go ahead and look at another question. The not equal is the one that causes us a little bit of difficulty in StatCrunch because of the way we have to use the calculator. So for number 6, we're doing mu1 not equal to mu2. So you still go back, let me open a new data table. You're still doing a T calculator, so we go Stat, Calculator, T, you use the calculators to find your critical values that they're calling T sub 0. Now, because it's a not equal, we're doing a two-tailed. Because it's not equal, we're doing a two-tailed, which is a between. But StatCrunch runs a little differently on the between. They told us that alpha was 0.01, so that would be the little pieces on each end. But StatCrunch will only run what's in between, so I have to run a 0.99. That's 1 minus 0.01 or 0.99. Now, for part A, where they're equal, I simply add 19 and 22 and subtract 2, so that gives us 30 for our degrees of freedom. So if I compute, my values are a 2.75 and a negative 2.75. So I'm just going to do a Control, I'm going to do a Control C. I'm going to close that. So for part A, for number 6, and I'm going to have to spread this out a little bit because I'm going to have to do some inequalities. I'm going to do, because it's two-tailed, I have to do a left and right. So for the left, negative T sub 0 would be equal to, sorry, let me add this in. Negative T sub 0, the critical value, be equal to a negative 2.25. So that's one critical value, and then T sub 0 equal to 2.75. The positive value would be your other critical values. So this one is our left critical value, and this one is the one on the right. And if you look back at that table, you will see the left value is a negative 2.75 and the right value is a 2.75. And that's all they wanted us to do, was to find those critical values for those particular problems. I'll do another part to work some problems where you have to do